Yeah. Look at all of them.
Hi, this is Miss Slitton, and this is Friday afternoon, and we are reviewing Chapter 46 while we're eating. I'm eating a salad. It's really good. All right. First thing you want to make sure you understand is the difference between weather and climate, right? And the example I give you, like a real cheesy example I give you, is that weather is your outfit on the day, what you're wearing that day because of the conditions of that particular day. But climate is what's in your closet over time for that particular area. And that is based primarily on temperature and rainfall. But we know, because we've had discussions about this, bodies of water can influence the climate, right? Mountains can influence the climate. The location where you are, like absence of bodies of water, if you're in the middle of a continent or something like that, that can influence it. So all of those are combinations that influence which organisms can survive where. And when we talk about climate, we want to differentiate that you can have microclimates, and then we would, when you talk about climate, that's basically a macroclimate, would be when we just discuss climate. But the bottom of a leaf would be different temperature-wise than the top of a leaf. Then you're referring to microclimate. And one thing we can say about climate for us is that it's warming. Overall, it's going to fluctuate up and down, but overall our climate is warming. And the concern is that happening as a result of man's impact on the environment. We talked about things that change those climates. One of those things that change those climates is our Earth is a sphere. And so yes, the whole side is lit up. On one side it's daytime, but when you look how that energy is spread out, we looked at for the same amount of energy when we look in this area, we can compare the amount of energy in one area, and it's the same amount of energy in all those areas, but it's spread out over a much larger range of the Earth. And so as a result, there's less overall energy as you go towards the poles because there's more areas that are sharing it. So that's one thing. So that's why it's colder at the poles. Then the other thing is we have seasons, and that's due to the what? Tilt of the Earth. Good. Sometimes we're tilted towards, sometimes we're tilted away. So that's going to affect things like temperature, right? And then the other issue we have is rainfall. Can temperature affect rainfall? Yeah, because if bodies of water, and how much of the Earth is water? 75%. Mm-hmm. 3/4 of the Earth is water. And so when you have that direct heat, like at the equator, on the water, what's going to happen to the water? The water is going to warm up. And we know that water changes its temperature more slowly than a terrestrial area. It loses it. But it will re-radiate that heat back out, and then that will heat the air above it. And what will the air do when it gets heated? Rise. And then if it has any moisture in it, as it gets colder, it can hold less and less moisture, so it will rain. And as it goes up higher and gets colder, it'll start to fall because it's density, right? It will start to fall. And when you have that circling of the air like that, that creates what? Winds. And then winds over water create what? Currents. I was just reading an article about the North Atlantic current, and they're seeing it slowing down, and they're very concerned, and they're relating that to global warming. And the current is starting to slow down. And if that starts to happen, big time problems. Anyway, so we saw that if you're in an area that's directly where the heat is going, you're going to get a lot of moisture like you would see in a rainforest. It gets a lot of rain because it's warm. But then what you typically see neighboring a rainforest is a what? Desert, because it's dry. Yeah, hot and dry. So we talked about climate, we talked about winds, we talked about El Nino. And we can see in these two pictures, what's the difference in the water in these two pictures? The temperature of the water. It's warm all the way across, right? And so as a result, all of this, you have this warm water, warm air, you're going to rise not in one spot, but in two spots. And an area next to where the air is rising is going to get the rain where it typically would be somewhere else in a different region. Okay, and we looked at how mountains can impact when you have rain. You're going to have more rain on the windward side of a mountain, as long as it has accessibility to some kind of moisture, right, that it could pick up. And then on the leeward side of the island, it's going to be, or a mountain range, it's going to be very dry. And our really good example for that was the Sierra Nevadas and Yosemite versus Mammoth. Okay. So windward, leeward, you want to make sure you understand that. And then also it's in, the way you remember rain shadow is it doesn't get the rain, but it's like, I can see the rain. And all you're getting is the light blocked by the rain. That's why it's called the rain shadow. And the rain shadow is a dry area. Okay, we talked about how due to the earth cooling more rapidly and heating more rapidly, that you tend to have onshore breezes in the morning because the earth's heating up, the air is rising, it's going to get replaced by oceanic and cool breezes. And then in the evening, the earth will cool down quickly, and due to the hydrogen bonds in the water in the ocean, it's going to be re-radiating that heat more slowly. And that air is going to be rising there and pulling the air to replace that vacuum off the land. So that would be an offshore breeze. So when we study climate, we know it's a result of temperature and rainfall. Then what can influence those things as well? Bodies of water, the topographical features, whether or not you have a mountain or not. All of those are going to come into play. So it makes sense to us then when we look at monsoon climates, when you look like you're in a warm area, like India, okay, and you're surrounded by bodies of water, the land is going to heat up, right? And here comes in the moist air to replace it, and you're going to get a whole bunch of rain, and you'll get that monsoon climate. We looked at things like lake effect. If you're in the middle of the United States and you've got a body of water and air starts to move across it, it's going to pick up moisture and then drop that moisture as snow. And we could see that occurring here in this picture. Okay, then the next thing we looked at was at a climograph, and I think I gave you one also in your, and how you can just based purely on temperature and rainfall. It's not topographical features, but purely on temperature and rainfall, you can pick out all your biomes. And not that you're going to have to memorize them, but you want to just make it make sense to you. If we work our way this way, right, and taiga would be like a coniferous forest, right, and then we have tundra. Right? So we could say things, we are decreasing the amount of rainfall as we work from right to left, right? We're decreasing our rainfall. And then as we go up vertically, in this particular, the way it's drawn in this way, so you have to make sure you read your axes, right? That we're decreasing our temperature. And so in this area, this would be closer to the equator, we have a lot of rain, we have a lot of heat, so we can have those broad-leaved trees, right? And now we're going to back off a little bit, and we're going to have, in this deciduous forest, this is like that Disneyland forest, nuts and berries and oak trees, right? And then we're going to back it up a little bit in taiga, and we have needle-like leaves. These are Christmas trees and our Hanukkah bushes. And then back it up a little bit more in the tundra, we don't have any trees, right? And the tundra and the desert have something in common. What do the tundra and the desert have in common? No precipitation. So one is a hot, cold, right? Because it can't hang on to the heat at night, so it's going to be cold. And then the tundra is just going to be cold all the time. And because it's cold all the time, you have what? That layer, what is it called? Permafrost. So it's not the top layer, because that can warm up in their very short summer, but the layer right below that of soil. And the roots of trees cannot penetrate that permafrost. So even if you had enough moisture, if you had snowpack melting, the roots can't permeate that permafrost. And then we said another way to experience all the biomes, you could move towards the poles, or you could just go up a mountain and you could experience all your biomes there as well. Same conditions. All right, and then we talked about aquatic biomes, freshwater, saltwater, or a mix. What's a good example of a mixed one? Estuary. And what's another thing about the estuaries we know? Tell me about the organisms that live there. They have to be what? Good osmoregulators. Yeah, because they'll probably be isotonic with the water. And what else? There's something else that's called the of the sea. Nursery of the sea. Mm-hmm. And how much of our water is fresh water? And where is most of that? glaciers, good job. Okay. And then we talked about the importance of evaporation of water from the ocean. We have a water budget, there's only so much water out there. And we talked about snowpack and the importance of snowpack. And wherever you have mixing, a lot of mixing, that water is going to be more oxygenated. When the water is stagnant, you don't have that mixing, and so that water can become very toxic. And if you have like a shallow eutrophic lake and it's got over-enrichment of nutrients and there's no mixing of that water, then you're not going to have, it's not good for biodiversity. All right, then we just started talking about the different biomes, and I'm not going to pull all those out. You can do that, and I've kind of talked about them already, you know, but tundra, you're going to look where you don't have a lot of seasons. It's going to be cold most of the year, and we've talked already about the characteristics of that. Here we're getting some seasons, right? Short summers, and we're getting those needle-like leaves like we talked about. Here, your temperate deciduous forest. These are like your typical Disneyland forests, and tropical rainforest real broad. And then we had another variation and huge biodiversity. And what's the ocean one that's similar to the tropical rainforest? Good. Shallow warm waters. What's a plant you would see here? Epiphyte, good. And you have resource partitioning, right, of the understory, because you can break it up and you have all those microclimates. Then we looked here at Oak Park. We have this dry, we have some, you know, enough rain that we have some trees and we have the shrubs, but we lose a lot of the moisture even though we're close to the ocean because of the mountains. Grasslands, not enough rainfall to support trees unless you're like in a riverbed, right? And deserts, not enough moisture and very, very dry. We move to our aquatic biomes and things like the depth of the water, the mixing of the water, how close you are to the shore, right? And that, just like when we thought about island biogeography, you know, we looked at how close you were, right? The salinity of it, all of those things are going to affect it, the temperature of it. We looked at different types of wetlands and estuaries. You're not going to have to memorize that, where it's acidic or not. Those are just examples. But we talked about the importance of wetlands and things like, you know, taking the less erosion because you kind of slow down the energy of that stream, that toxic chemicals can be taken out, that it provides a lot of habitats for different organisms, and the benefits that it's like a sponge, can hold that water for when you need it. And we looked at ponds, we looked at lakes. Then we just compared and contrasted the two types of lakes, and these are like either extreme, oligotrophic versus eutrophic. You know, these are clear, maybe cold, deep waters, and the eutrophic ones are over-enrichment and very murky. And then when you look at bodies of water, you're gonna have layers, just like if you jump into somebody's pool and the top layer can feel really hot, and then you swim to the bottom and it's cold, right? And that's just your backyard pool. So imagine that in a lake, right? You're gonna have the stratification of temperatures. And one thing that helps with the lake is that mixing that you're gonna have at least 2 times a year, the fall and spring overturn. And because of the changes in temperature and because of winds, you're going to start to mix that up, and that's really good for lakes because you get the nutrients from the bottom up at the top, and you get oxygenated water moving back down. Then again, we talked about, and again, you don't have to know all the terms, but benthic would be at the bottom. We talked about littoral as well lit, pelagic is open ocean, and the importance of estuaries again. And then then we talked about the importance of coral reefs. Is there anything, were there questions I skipped you want to do, or are you good? All right. So hopefully you've studied, and it's not Sunday night at 10:30 at night. And if it is, have a piece of toast. But just make sure it's whole wheat bread.